Dr. Mark Morgan is a professor and our extension specialist over in the food science department. He is involved with several projects, including this dairy business initiative innovation, looking at how small-scale processing equipment could be used for our dairies across the state of Tennessee and the Southeast. He's also helping us put together some extension publications, as well as working with us on some cost estimates for all the equipment he's going to talk to you about today. And we are very glad to have him here with us. And Mark, I see that you have...
All right, welcome everyone. It's a pleasure to share a few words with you about dairy processing equipment, especially small scale. I assume some of you are already using some small scale dairy equipment. Others of you may be wanting to get into the operation. So hopefully I can share a few things that you can consider and resources you can try to use to develop your operation. So we'll focus mainly on milk, and then we'll get into a little bit of cheese and ice cream processing equipment, since they typically build on already having some milk processing equipment as well. So if we look at milk, there's a lot of different products out there that characterize milk that you can sell. And it really comes down to what is it you're trying to market? What is your niche for a small scale dairy? And a lot of these different types of products require different equipment. And so the costs may be vary depending on that, right? So if you're just making a cream line product, you don't need necessarily a homogenizer or a separator that can reduce a lot of the costs. So let's start out with just the regulatory issues. So, you know, the milk is a highly regulated product, and this document we call the FDA Pasteurized Milk Ordinance, PMO, is basically the Bible for all regulators in ensuring that milk products are processed and delivered safely to consumers. And so, but this qualifies only, or this milk only applies to those that are consumed as a beverage for the PMO particularly. And but it also includes things like cottage cheese, yogurt, and some dry milk products. This document ranges from the farms producing and the milk all the way to the facilities for processing and packaging, and as well as the equipment. And we know that there are some regulatory requirements for the quality of that milk that comes from the farm. And all I want to say at this point is the better quality milk you have, the better quality products you're going to make, all right, in your processing facility. Your processing facility can't do a very good job improving on poor quality milk that comes in. So that's just something to think about. All right, so all milk officially sold in Tennessee for human consumption must be pasteurized. That's typically true across the country, even though there are some states that have a few other options available, let's say. But the key is that milk and milk products grow bacteria very quickly if we don't temperature control them. And so if we don't keep the product very cold, then bacteria will grow. Milk has a pH range right in the optimal area for pathogens or bacteria to grow. And so we try to cool it immediately after milking, and anyone that has a dairy knows that. And then we try to keep it at those low temperatures as much as we can throughout the processing. So the other big piece about processing dairy products is the sanitary design of equipment and facilities. So equipment and facilities themselves can quickly contaminate milk with bacteria. Even if you're getting very clean milk from the dairy and from your cows, once it gets into a processing plant, if that processing plant is not rigorously cleaned and sanitized, then there's chances for microorganisms to survive in that environment and contaminate the raw milk or the processed milk. So the raw milk storage tanks are cleaned and sanitized every time they're empty. Any tanks are emptied every 72 hours at a minimum. So you can't hold that raw milk longer than the 72 hours in a processing facility. And then all of the equipment that's used in processing facilities, dairy processing facilities, is what we call sanitary design. So this is a design approved by a third-party organization called 3A. And 3A was originally developed by producers, processors, and sanitarians. And they look at the design of the equipment to make sure that it is easily cleanable, that there's no crevices that will trap bacteria, there's no dead ends that will hold up product for long periods of time where the bacteria can sit and grow. The surfaces of the equipment inside and out are very smooth, again, easy to clean, and the product and the equipment's easily drainable. So again, between operations, we don't have stagnant product or cleaning solution sitting inside of the equipment. So the PMO for pasteurized milk that's sold across state lines, all of it has to be of sanitary design, and this 3A approval process, I have an emblem later I'll show you. If that's on the equipment and that equipment has been certified by this organization, then it's easy to use that in your processing facility. If it's not, then your regulators are going to be very anxious about allowing you to use that equipment or cautious, and they're going to scrutinize it very carefully to make sure that it still meets the same criteria as a piece of equipment that is 3A certified. All right. So this sanitation is key to having a quality milk processing operation. And if your equipment cannot be cleaned very easily, then that makes it even more difficult. All right, this just says which is highest quality. So when you're making a milk product, you know, the key for a small dairy is trying to sell it as a high quality product. And, you know, I don't know what your opinion is looking at these containers, but this glass jar brings me back memories of the milkman dropping off the milk on the back step in glass bottles like this. And we think that is a higher quality product. The glass containers are a little more expensive. You know, we all think that anything made out of plastic is cheap. So, you know, that a lot of people are trying to come back to the glass bottle scenario for these small niche processors to try to sell your product at a premium price. And as we go through this, you're going to see that the equipment and processing is not cheap. And so trying to get a premium for your product is going to be key. I think that's what maybe the next speaker will talk about. But just to look at the different types of products, I also want to point this out. So whole milk, what we call whole milk, is typically standardized to 3.25% butter fat or fat content. But whole milk, the definition can be anything at 3.25 or above. So even this creamline product, which is just the milk taken out of the cow and pasteurized and put into a bottle, it could vary in fat content based on what kind of cows you have, what they're fed, what they're producing, etc. If you're also, a lot of products people want to drink is reduced fat milk, 2%. And if you're going to produce a product that you say is 2% milk, guess what? You have to be sure you can control the fat content to close to 2%. And the same thing for 1% or skim. Now, skim milk is a little easier because, you know, there are ways to just skim off the cream, and what you're left with is, by definition, skim milk. Typically, it's less than 0.5% fat. And it's considered fat-free because any food product with less than 0.5% fat is, by definition, considered fat-free. So standardization, anything that has a specified fat content on it, you'll see will cost more money to produce because you have to have more equipment to do that. Finally, this last one, this Nestle product here, is in what we call a aseptic carton. And this milk is not refrigerated. So this is what you would find on your grocery store shelf. The rest of these all have to be maintained in refrigeration conditions during storage, during transport, and when you take it home and put it in your refrigerator. But this milk on the right is what we call aseptic or UHT milk. And this UHT milk has been heated and processed at conditions that will render it essentially commercially sterile. So it can sit on the shelf in the grocery store aisle and for up to a year and not spoil in that container. So it's sterile container, essentially sterile milk put into that container. And we don't use that a lot in the US. People who may use it for, keep some for emergency use or baking or something like that. It definitely will have somewhat of a cooked flavor because of the high temperature it's processed at. But that is what we call UHT. The rest of these are all pasteurized. Typically, these commercial products are pasteurized in an HTST, and the cream line could be in either process available. So just to look at the typical processing scenarios for milk, we have a raw milk tank or a truck. You could actually pull the raw milk right out of a truck or the bulk tank. And typically for commercial operations, that cream will be separated off. The cream will go to a storage area, and then the skim milk will go to a mixing tank where we standardize to the fat content that we're targeting. And then typically that milk is homogenized. So we break up the fat droplets and a smaller particle size so that they don't separate anymore. And then we'll pasteurize it. Part of pasteurization is cooling and then sending that to a storage tank for bottling immediately or sending it right to a bottle filler depending on the operation. So this is what a commercial process would look like. But for for those pieces or products that are standardized, you have to have all of this equipment in order to be able to make those products. But this isn't the only way that small dairies can get started. Luckily, there are alternatives. And one is to take that raw milk, make the cream line product, something that is not standardized, not homogenized. It could, and just send it right to a pasteurizer. That could be the whole milk, or it could be that you leave the milk in this tank for a certain amount of time for the cream to rise to the top, skim off the cream, and then the skim milk could be sent to a pasteurizer and bottled as skim milk. So that's an alternative way of processing with less initial costs because you don't have to have this type of equipment to operate. You could homogenize if you wanted to, this cream line or this non-standardized product. Just add the homogenizer in there to prevent the milk from separating in the bottle, and making some consumers may think that a separated product has gone bad. They have to be educated for sure that this is, if you're not homogenizing, that it is, the cream will rise to the top and separate within the container. So homogenization will prevent that. Some consumers like that, some don't. Okay, so if we just want to go through this process step, the raw milk receiving, a bulk tank, or here's a good picture of a tanker on a truck that's used to pick up the milk at a dairy close by and taken to the processing facility. That milk has to be kept cold, so it will be chilled rapidly at the dairy down to about 45 degrees. When you get it to your processing facility, it has to be checked for antibiotics. Typically, it's checked for quality as well. You're looking for off odors in that milk. You're looking for any debris or anything that may be show that it's a poor quality. They may do cell counts, things like that to check. If it's your own milk, then you have the history on it, so you can take it right from your milking parlor to your processing facility and start working with it. Typically, it's filtered as you're pumping it off of this tanker truck just to remove any foreign objects that may be got into that tank. It's cooled and processed immediately, and because you can only store that raw milk for 72 hours in the process facility. So you have to have approved milk tanks. These tanks have to be well insulated if you're traveling very far with that product. Has to be kept cold. If you're going to transport milk, or even if you're just taking it from your dairy, you have to have the tank cleaning station, someplace to rinse out the tank, wash it with detergent, sanitize it. That requires some ancillary equipment as well. Here's an interesting option that this small dairy used. They had that tank on the truck, and to clean it, they would roll it off of the truck and into an area where they had hot water and drains and a system where they could hook up lines to clean the tank in place and prepare it for the next use. Part of this facility used to be their milking parlor, and they got rid of their milking parlor, and now they're buying the milk from a nearby dairy. So that's an example of small scale processing. And this tank, again, is well insulated so that you can maintain the temperature. Typically, the milk has to be unloaded from these tanks under cover so that you don't have any chance of the weather or external environment affecting the product coming in. And so you can see here that they've got looks like a cover over this area. If we move on then, so once you've got the milk in your facility, if we move on to pasteurization, for small operators, there's two options: the batch or vat pasteurization. This is going to take some time, but it's good for small operations. It's a lot less equipment up front. But as you grow, you're going to realize that the continuous inline pasteurization is going to perhaps be more efficient, more cost effective, and less time consuming. So we'll cover both and just talk about the equipment and the processing conditions for each. So vat pasteurization, you're basically putting that milk into a agitated vessel where you've got a good agitator to keep it mixing. And then you've got some sensors to measure the temperature in there. You've got a heated jacket to heat the tank, and then a valve to pump the milk out when you're done. And actually the jacket is probably used for both heating and cooling, all right, during vat pasteurization. For inline pasteurization, you're taking the milk out of a bulk tank and you're pumping it through your process. So you're pumping it in here through what we call a plate heat exchanger. And that milk will go through and get preheated. It'll in a couple of stages, and then finally it'll go through a heating step where you've got some hot water, for example, going through one part of the heat exchanger, and that transfers the heat to the milk to bring it up to the required temperature. And then while the milk is flowing through this pipe, you need to hold it at that temperature. And so it flows through a section of pipe we call a hold tube. And as it flows through this hold tube, we know that it was at the right temperature. The time it takes to go through this tube is the time that we're going to hold it for pasteurization. If that's 15 seconds, then the flow rate and the length of this tube determine how long it's in there. And then you obviously have to have a pump to pump that material through the process line, and then you'll come back and start to cool it back down. Finally, with cold water, you'll cool it back down and send it to the bottling station or another bulk tank to store it for bottling. There are typically these are all computer controlled for temperature and even pressure in this system. And so that makes it a little more costly to make sure that operation is fairly well automated or controlled. So if we look at vat pasteurization and why we would choose it, it's the easiest for small batches of product at a time, maybe up to a couple hundred gallons. You only have to heat the product up to 145 degrees Fahrenheit and hold it there for 30 minutes. And then during that time, you're continuously agitating it, and then cool it back down after the 30 minutes is done. This is overall a slower process to actually pasteurize 200 gallons of milk. And so it's going to take a lot longer time if you have the time to do it. Some people prefer the vat pasteurization because of the low temperature. And so it will do less, give you less of a cooked flavor to the milk, for example. And it requires less automated equipment. If we look at inline pasteurization, HTST, high temperature short time, is what's used commercially. Now we're talking about 15 seconds to pasteurize, to hold the milk. So if we're pumping the milk at 5 gallons a minute, then we're pasteurizing about 20 gallons a minute. So in 100 minutes, we would have, or in 10 minutes, I guess, we would have 200 gallons done. A much quicker operation. This is what's typically done commercially, is HTST. There are higher temperatures in the PMO. So all these times and temperatures are specified by this pasteurized milk ordinance. These are legal requirements. A lot of times you'll go a little bit higher just to make sure you meet that legal requirement, but these are the minimums for legal pasteurization. Higher temperature or higher heat, shorter time, you can go even shorter time pasteurization. And then ultra pasteurized, which you'll see in some commercial products, is all the way up to 280 degrees Fahrenheit for just a very, very short time, 2 seconds. So how do you heat it up and cool it down very quickly? Typically, it's some sort of steam injection or steam infusion so that the milk heats very rapidly, and then they put it into a vacuum chamber so that it cools very rapidly. So it goes up and down very quickly and only sees that temperature for a few seconds. That milk is typically filled in a filler that is also very sanitary so that they can get extended shelf life in that product. And if you go even further and do the ultra pasteurization with an aseptic filler, that's what we call the UHT processing. And this is where that shelf stable milk can be made, where you can set it on the shelf in a carton and not have to refrigerate it. Okay. So these are just the different options. Typically, most new operations are down here starting with the vat pasteurization because it is less costly equipment and the time, assuming they have the time to run the operation. And that may be a selling point for their product. So what equipment is involved? Well, here's some small examples of vat pasteurizers. You have to have the temperature sensors on them. You have to have, ideally a 3A certified vessels. This may be the cooling system. So this has a jacket around the product so that you send the heating or cooling media around the vessel to heat the milk inside. Temperature chart recorder is typically required so that you know that that batch of product was heated up, held for the minimum 30 minutes, and then cooled back down. These things cost, $10,000 to $15,000. You're only talking a very small size, 15 to 30 gallons per batch. So if it takes you an hour or an hour and a half to do a 30-gallon batch, you're not going to do a lot of volume in a day, right? That's just the pasteurization step. And you still have to put that into bottles or containers. If you go up to a larger vessel, very similar operation, same equipment required, you're going to get incrementally higher in cost, but not so much. And this would allow you to do, up to, perhaps 250 gallons or something based on the size of that vessel. Here's another example, a very small one by another company. This has all of the requirements for a 3A certified system. So this is the pasteurizer vessel. It is electrically heated around the tank. And then they use this refrigerator, or this freezer is used to cool the water that they'll pump around the jacket of this to cool it back down. It's got the sensors on the top of it to measure the temperature and agitation. Here's your chart recorder to keep track of that time and temperature. Here's a pump that they'll use to pump it out and pump it into this very rudimentary filler and capper for the containers. All of this is theoretically approved for use by under the pasteurized milk ordinance. So, but very small, very labor intensive because it's all on manual operation. And that may be fine if you're making a very small amount of product at a time. So this just shows, again, the chart recorder. This is a permanent record of that time temperature for the pasteurization process. To be legally sold as a pasteurized product, you have to have this record of that time and temperature process for the pasteurizer. And so there's typically a sensor in there that measures the temperature, and then as the chart rotates, it keeps track of time. So you can look at it and see when the temperature reached a certain value and how long it held at that value before it was cooled back down to ensure that that batch was pasteurized. So these have to be kept on record for that product. All right, if we move on to the inline pasteurization, so this is an example of a very small self-contained inline HTST. Has all of the required components. It has a balance tank here where we dump the milk in or pump the milk in, and then it has a pump to pump it through the system, the pipeline. It'll pump it through a heat exchanger in the back here, and then through this hold tube I showed you to hold it for the 15 seconds, and then comes out, and then you would send this to a storage vessel, or send it to a filler. There are some valves on here to automatically divert the flow. So all of these are computer controlled, so that if the temperature isn't reached at the end of this hold tube, then it will divert the product back to be reprocessed. In Tennessee here, when these are approved for use by our regulators, they will come out and they will check the time that it takes for the milk to go through this hold tube based on how fast this pump is running. So it has to be set for a certain flow rate. Let's say 2 gallons a minute for the product. And once that's set, they'll lock this panel so that it can't be adjusted. You can't change the flow rate of that product. So in order to make more product faster, you would have to have a longer hold tube, because the hold tube length determines how long you're holding that product at the pasteurization temperature. So once this is designed for 2 gallons a minute, that's it, all it can do. You would have to either increase the temperature or change out the hold tube to process more product than that. So that's something to think in mind about when buying a pasteurizer unit like this. What is its maximum capacity for the hold tube, and can that be changed? So this item here, self-contained, is almost 100K or over 100K to do 2 gallons a minute. So a much steeper investment in equipment costs. All right, this just shows how the heat exchanger works. It's just hot water or hot heating media and milk on different sides of the equipment to heat it up and cool it down. Typically, we verify that a product has been pasteurized in a plant just by doing an alkaline phosphatase test. That's just an enzyme in milk that tells you whether or not the milk was heated long enough to inactivate that enzyme. And if the enzyme is inactivated, then we consider it adequately pasteurized. All right. So let's say that that's all you really need to go this route for pasteurization. Let's say you want to go into more detailed process with homogenization or cream separation. Now we have to look at other pieces of equipment. So if we're thinking about a cream separator, this is a very small cream separator, that a tabletop unit that could be used to separate cream. What it typically will do is put the milk in the top, it spins, and since the cream is lighter, it accelerates the rate at which that cream will separate from the skim milk and come out in two different streams. So typically we do the milk separation cold when the milk is still cold prior to pasteurization. The skim milk that comes out is typically already less than 0.5% butterfat, but the cream is only about 10 times higher than that, so than the original milk. So if the milk was 3% fat to begin with, your cream that's coming out, so quote unquote cream, is going to be about 30% fat. Or if it was 4% butterfat in the original milk, it may be 40%. So it's not pure cream; it's cream and some milk as well. All right. And so typically these are stored in separate tanks prior to pasteurization. This is a large separator. It's hard to get a small commercial size separator. A lot of small operations will use, if they are going to separate, they'll buy a used piece of equipment. And one of the challenges is getting a small enough piece of equipment to operate at your flow rate. So this fairly small unit can do 2,500 gallons an hour, which is quite a bit. And so trying to get a unit between these two sizes is sometimes a challenge as well. We'll just skip that for the moment. All right, so standardization. So you've separated the cream, the quote unquote cream, from the skim, and now you want to make a 2% or a 1% milk, a product. So typically you have to blend these products back in, blend some cream back into the tank with your skim to reach the 1% fat content. And in order to control that accurately, you need some way to test it. Well, the standard industry equipment is something called a Milk-O-Scan by Foss. And guess what? These are about $40,000 new. Now, there are used ones out there that work very well, some older models, but that is going to be probably the best way to actually try to control that fat content, 1% or 2%. You can sell skim milk, so you could separate and sell skim milk without having to have this Milk-O-Scan to check the fat content, just by determining how much time it takes for your cream to rise to the top, and then collecting data to show to the regulator that, yeah, I've had this milk sent out and tested, this skim milk, and that I am waiting long enough for the cream to rise, and it is considered skim milk. So that's just a time temperature thing that you need to standardize for coming up with skim product. All right, so this is a fairly costly piece of equipment to try to do standardization. So probably not recommended for new operations. Stick with the whole milk. If you're going to want to homogenize, and I know not everybody does, and that's fine, but basically homogenization just takes the raw milk with these larger fat globules and forces them through a very high pressure valve so that it breaks them up into smaller fat particles. That's it. And these smaller fat particles take much, much longer to cream to the top. Then gravity doesn't pull them up, allow them to rise up as easily, or they rise up. Yeah, they're more suspended in the milk, so it'll stay separated a lot longer, or homogenized a lot longer. Just a high pressure valve. That's all we do is pressurize it to 1,500 to 3,000 psi, and when it pushes the milk through there, it shears those larger particles into smaller droplets. That's all there is to it. A homogenizer, again, not a cheap piece of equipment, $30,000 plus for a small homogenizer. All right. If you're using an HTST, typically the homogenizer is that timing pump that controls the flow rate of the product through the HTST. And remember, I told you that if the whole tube is set up for 2 gallons a minute, then you have to pump at 2 gallons a minute. And typically we use the homogenizer as that pump to do that. Here's a larger homogenizer, many different valves, much higher cost, in the hundreds of thousands of dollars for something like that. But there are very small ones available as well. Okay, so this is basically the setup for this HTST system: raw milk, cream separation, standardization, and then all of this is the pasteurization step, heating and cooling, and and homogenizing. Here's your homogenizer, pushing the product through the heat exchanger, and then putting it into storage. So if you're going to standardize, yes, you're going to probably, depending on how big you are, you're going to have separate tanks to store the cream and the skim milk, and then the raw and the processed milk perhaps. Now, if you're very small and you're separating cream from letting it rise to the top, 5-gallon buckets, skim it off into 5-gallon buckets, put it in the cooler until you need it, right? Or want to use it. That's maybe you're going to make ice cream or something with it. That's acceptable as well. But you're going to have some sort of containers for the separate products. Then the final step in the process for milk is just the packaging. Choosing what kind of packaging material you want. Milk is always cooled down before it's put into packages and kept cold. So that means that those containers must be very clean and sanitary. The packaging equipment must be sanitary, and the environment has to be fairly clean. And typically the filling and operation, the packaging and filling operation runs slower than any HTST would run. So that is going to force you to have some sort of a bulk tank or intermediate storage tank for that pasteurized milk, because the HTST is going to have that milk pasteurized much faster than you can fill it in most cases for a small operation. There are different types of fillers, semi-automatic and automatic type fillers for small operations. Here's a very small, probably the simplest commercial style filler you could find. So there's a pump down here pumping the milk up into this container, which is then, as the bottle goes in, it's filled there's a valve that opens for a certain time that it takes to fill that container, and that's programmed on a panel. And the person is manually moving the empty bottles and the full bottles to the capper on this carrier. So this is a handle. Person just slides it to the right, picks up an empty bottle, slides it to the left, fills one bottle while it takes the full bottle and puts the cap on it. So the caps are up here. They slide down this. They're dropped on top of the bottle, and then this plunger pushes them down and snaps on the cap. So this could be plastic bottles, this could be glass bottles, but this is about the simplest commercial style filler that I've seen. And we're talking about $12,000 to $20,000 for something like this. If you want this to be more automated, where there's a rotary indexer here and a conveyor, so the empty bottles come in, they go into the indexer takes them to the filler, to the capper, and then out. Now you're talking about $30,000. And there are a lot of videos online to show how those operations work. And then as you go up in production, there are multiple head fillers. So this is a single head one, just has one filling station and one capping station. There are ones that have 2, 3, 4, 6, 9 different types of fillers and different numbers of heads, so you can fill at a faster rate. This is probably adequate for a small operation. All right, so just to summarize the milk part, all the equipment and facilities used for bottled milk must meet strict design criteria. And those criteria are typically in this grade A milk pasteurization ordinance document. Unfortunately, this document is almost 450 pages, which is huge. Hopefully, if you're just making one product, then maybe a lot of those pages don't pertain to you. But it is a legal document. It's sometimes difficult to understand and get through. If you have trouble sleeping at night, this is a recommended reading. And regulators will typically use this to decide what you can and can't use for your equipment and facility. The key is that the regulators that are going to regulate your operation are usually very good at helping work with you to meet these requirements. So my biggest piece of advice, if you get nothing out of this talk but one thing, contact your regulator early in the planning process before you've ever bought anything or built anything, because they will tell you, even if you have I'm thinking of buying this, they can look at it and say, yeah, that's okay. It's got a 3A symbol on it, or these are the requirements for building your facility. Here, show them the plans. And before you break ground, they can look at that and tell you whether it's going to meet the requirements or not. The last thing you want to do is have something built, have your equipment in there, and now call your regulator and say, hey, can you come look at this? And they come in and find out that none of it meets this Bible's requirements for their regulations. And then you have to make a bunch of changes. Okay? So make sure you contact those regulators early and try to get them to help you out. One other thing is that for just bottling milk is sanitation is the key to having a quality product. So you have to spend money on sanitation, cleaning chemicals, a clean in place system or cleaning station or something. And you have to keep, rigorous procedures for making sure that all of your equipment is cleaned and sanitized prior to and after each use. That is going to affect the shelf life of your product for sure, the quality and flavor of it, because customer satisfaction, sanitation is key in your facility. All right. Okay. I don't know if we don't have any time for questions at this point, right? Or do we?
So we're going to need to clip along pretty quickly after this, but there are some good questions in the chat. And one of them is from one of our small ruminant producers. Can goat milk be sold to skim after separating, or is that just a cow's milk thing?
Oh, that's a good question. Goat milk doesn't rise to the cream to the top like cow's milk. So I'm not sure you can actually get it to less than 0.5%. Do you know any better, Liz?
I do not know any better.
I just know when I was a kid and raised dairy goats and milked cows in the morning before school, or goats before school, that milk is sort of naturally homogenized. It has smaller fat globules to begin with, so I don't know that you're going to be able to get it to skim without any kind of a separator.
Oh, with a cream separator. Excuse me. Thank you, Christine, for adding some more context. So could it be sold as skim after using a separator? Would those same breakdowns apply to goat milk that would apply to cow's milk according to the PMO?
I think so, but I would need to double check. So
that would be my response as well. The PMO is as far as the regulations and the standards. And in the beginning, when it's talking about what all is included as milk, it lists all of the different species. And to the best of my knowledge, the only thing that's different is, I believe, goat somatic cell count. And it's just goat. It's not also sheep. We have another question that I think would be really good to answer right now. It says, through natural separation, how long does it take to get to 2%, 1%, or skim?
Oh, that's a good question. I don't have any idea. I know that that people have done studies in their system on how to do that and how long that takes. So you would just put it in your tank and then collect samples from the bottom and see what that time is, for your operation. It may vary based on the temperature, on the equipment you're using. I really can't answer that either. I'd have to look. But I think we have some people in the state that are doing that, that are allowing it to just cream to rise and skimming it off the top. Mm-hmm. So it is feasible.
It is feasible. Okay. All right, Mark, if you want to give us the lightning round of cheese and ice cream, that would be great.
I don't have a lot of parts to cheese. So, I mean, there are different types of cheeses. The main thing about cheese is that there's a lot of different processes for cheese and types of cheese. And so it's a very complex mechanical, chemical, biological operation occurring. It all starts with that starter culture, what kind of bacteria are you putting in there to determine what kind of cheese you want. But if we look at the process, this is basically the bottom line. So the part here is basically your milk processing, and you may or may not standardize the milk that you're using in the cheese vat to make the cheese. You probably most cheese is made from pasteurized milk. There are some regulations to allow you to make raw milk, for example, and you just have to age it here for 60 days to make sure that it's pasteurized and maybe standardized for fat content. You putting it into a vessel, and your fermentation cultures, your rennet to separate it, and then you're cutting those curds, maybe cooking and stirring them, draining out and then milling and salting the curds, and then putting them into some molds. This is one example. And the molds are pressed, and then that stuff is set out to ripen or age in a controlled environment, depending on what quality you want. So what I want to point out here is that and then the milk used for cheese is normally not homogenized. So you don't need a homogenizer to do that, but you still may want to standardize the fat content. Here's some aging, putting the cheese in a controlled environment, temperature and humidity. Here's one where somebody made a cheese the aging process for that cheese. We are going to have
we have Q&A, and all that are joining. If you have more, please feel free to throw them in there. And the question is, does cheese like cheddar fall under the PMO regulations?
So I think so. Did I? No. The milk I don't think that the cheese is a grade A product. There was a cottage cheese perhaps, but aged cheese is no.
Okay.
So there are some requirements. Your regulators are going to want you to use the best equipment you can, so they're going to try to push you to use the 3A equipment for the milk part of it. But I don't think it's strictly governed under the PMO. Most cheeses. There are some exceptions. Cottage cheese, I think, is.
Mm-hmm. So those extremely fresh cheeses.
Yeah, and the fresh ones, yeah.
This is another good question. For the small scale processors, what do they do with the whey? And I know you mentioned earlier, Mark, sometimes you just put it into the septic system if it's a really small amount. We've had a couple producers that actually will feed it to hogs if they have show pigs. They'll feed it to show pigs. And if you have enough of it, this is something that we were really looking at when we were having a lot of producers have to dump milk. But some of the larger cheese producers actually will put that whey back into the dairy cow ration. Now, if you've only got 1 or 2 cows, that gets a little bit dicey because that means you're rebalancing the ration kind of randomly instead of having it be a constant feed additive. But anything else besides that, Mark?
So again, if you had a large amount, there are places that will dry it and make whey protein isolate. You can try to do that, try to dry it. Again, more equipment and cost. I don't know if you'll be able to find somebody to take it as the whey byproduct for that purpose, but there may be. A lot of protein drinks and protein, high protein powders are from whey protein that comes out of this drained whey. So there is some value to it if you had enough that made sense to extract that value.
Okay, perfect.
But typically most small people are not going to bother. They're going to just figure out how to dump it or use it for feed or something.
Okay, perfect.
All right, move on to our favorite, everyone's favorite, ice cream. All right. So again, not a lot here, just a little bit about, ice cream has a standard of identity. So legally it has to meet certain criteria, at least 1.6 pounds of total solids in a gallon of ice cream. And that gallon must weigh at least 4.5 pounds. Not less than 20% total milk solids and at least 10% milk fat. Now, a 10% milk fat ice cream is probably one of your lower quality ones. Typically, you want higher than that, 12 to 15% or something. that is what we call a premium or a higher quality ice cream. The key to ice cream quality is this overrun. An overrun is just the amount of air in the product. So if I have 100% overrun, that means that 50% of the cream is just air. And yeah, selling half of your container is just air. So why would you buy for a regular price? And because otherwise it feels big, and everyone had quality ice cream that tastes milk as ice cream. And during storage, keep together and increase the size of the crystal over time. If you've opened a can of ice or a container of ice cream that's been in your freezer for a while, you'll see a lot of ice crystals on the top. All right, there are some emulsifiers and things people making it smoother or stabilizers to reduce that ice cream crystal growth. But typically, a small operation trying to all natural quality ice cream may not have any of that in it. May just be may not have those. So there are different marketing terms, but this is the key. So this is the ice cream mix, which has water, sugar, milk, solids, non-fat, and fat. And then we make it into ice cream, 100% overrun. Look, all we've done is added air and frozen all the rest of this. So the percentages go down in terms of the total product because half of it's going to be air whipped into the cream. All right, so the equipment, basically all the same up through, this point. You're adding sugar and any flavors and things into your pasteurizer, and then you're going to pasteurize that. You have to pasteurize it at a higher temperature because of that sugar content, and then let it age for a while. Throw it into a freezer, whether it's a batch or continuous freezer. Put it into your containers and then harden it. Hardening it is making sure that it's, the difference between soft serve and containered ice cream is that the container you buy has been hardened, right? Much colder temperature so that it lasts longer. Soft serve ice cream won't last very long unless it's colder. All right, so there are different pieces of equipment, the different batch or continuous freezers. Both of them use scrapers. If anybody's made ice cream at home, the little scraper. And then the rapid freezing is the highest quality, of course. Finally, you put it into a container. So if you've got a continuous freezer, then you're going to need a filler that can keep up, because you can't store this in a tank. You can't take it out of the freezer and put it in a tank and fill it later. You have to go immediately into your packages. And so this is a 2-head filler so that you can continuously handle the flow of ice cream coming out of the freezer. If you're using a batch freezer, then you can fill containers by hand by just opening the opening of the batch and pumping it out into the different containers. This is some pictures from Clemson's operation. So again, not a lot of detail, but the main thing is having a hardening freezer, or blast freezer, and then the batch ice cream freezer is probably what most small operators will start with. And we're talking, $20,000 to $30,000 maybe for one of these as well to get that operation started. All right. Questions on ice cream?
Well, so far there's nothing in the chat, but guys, we have about 4 minutes. So if you have a question, ask quickly. And if we don't get to any of your questions today, don't worry, don't panic. You all have my email address because it should have gone out with the webinar link. So feel free to send me any questions that you don't get a chance to ask today, and I will pass them along to the appropriate presenter and get that information back to you.
Yeah, so one thing I didn't mention about ice cream processing is, let's say you're starting out small and want to build the market for your product first. You may want to avoid all of this and not start with raw milk. You may want to start with a pasteurized ice cream mix that someone else has already made for you. So you just have to take that mix, put it into a freezer, add your flavorings or inclusions, whether it's nuts or chocolate chips or whatever, and freeze it, and then fill containers and then harden it. And if you have a dipping station, you're going to make the most money selling it by the scoop. So if you have a ice cream store where people can come in and buy it by the scoop, you're going to sell it. You're going to make the most money by doing that. And so you would fill it into 3-gallon tubs, like is shown in this picture, and then that's what you would scoop out of in your store if you had an ice cream store. But you don't have to get started by pasteurizing your own mix. You could easily buy one or have someone else prepare that mix for you.
And that's been a pretty successful model that's been employed across several southern states, especially for people who are still trying to fill out the ice cream market in their area, and
Right.
they don't want to invest all of that time and money into their own processing equipment. We've had several, and you'll hear from a couple of them this afternoon, that were very successful using an ice cream mix and adding their own stuff to create their own flavors.
Yeah, because that's a huge investment for an operation that doesn't have a market clientele yet, right? You don't have a consumer base yet, and so this is a good way to get that consumer base built up and then switch over to making your ice cream out of your own product.
Thank you, Mark. We really appreciate your time and your expertise.
Okay, be glad to help anyone if they have any questions.